Hey, it's a video on just some intro to logs. So we're going to start with forms. So we can convert between an exponential form and a logarithmic form, just seeing this. So if we have an exponential form, b raised to the exponent y is equal to x, what that looks like in logarithm form is log base b of x is equal to our exponent y. We call this the base, as we do in our exponential form. We call this the argument. And this is our exponent. Okay, so if we want to switch between forms, we can do that. Let's say log base 2 of 16. We could rewrite that in exponential form by saying 2 to the power, well, maybe I should have made it equal to something. Well, let's say it equals 4. So then I can write that as 2, I should not put an equal sign. We can write that as 2 to the power of 4 is equal to 16. So base of 2, exponent, and the argument. So that's how I can convert between the forms. If I wanted to write 3 to the power of 2 equals 9 in logarithmic form, I would write it as log base 3 of 9 is equal to 2. And the logarithms are always equal to the exponent. Okay. And now let's try evaluating a couple of logarithms. So I'm going to talk about a common base, but I'm not only going to talk about that. There's other ways to think about it. So if you have log base 2 of 32, basically you're kind of thinking 2 to the power of what is going to equal 32. So sometimes it's just nice to write the 32 as a base of 2. So 2 to the power of what equals 32? Well, 2 to the power of 5 is equal to 32. So now I know my answer must be 5. Because this expression is basically saying 2 to the power of what will equal 2 to the power of 5. So obviously 5. Okay, this one, log base 4 of 1 over 4. What does that equal? Well, I know that with my knowledge of negative exponents, I can actually write this 1/4 as 4 to the power of negative 1. Because I know that 4 to the power of negative 1 is equal to 1 over 4. And now I can get my answer as just negative 1. Or you can just think about it as, if you were to write it in exponential form, 4 to the power of what is equal to 1/4. So it has to be negative 1. Okay, a couple more. Log base 4 of 64. So I'm thinking 4 to the power of what equals 64. If I know right away, I can just say 3. That's the answer. Or you can write it like log base 4 of 4 to the power of 3, and then you know your answer has to be 3. Okay, this one. So I have log base 25 of 5. So I have to think like, how can I write that 5 with a base of 25? So log base 25, 25 to the power of what would equal 5? So since I know that fractional exponents will make this 25 actually smaller, that's what I'm going to go with. So I know 25 to the power of 1/2 is equal to 5. Because I know a 1/2 exponent is like the same thing as doing a square root. So I know saying 25 to the power of 1/2 is actually the same thing as just saying 5. And now I can say that this expression would be equal to 1/2. So 25 to the power of 1/2 is equal to 5. So that's how we can evaluate some logarithms. So when we are saying evaluate a log, we're looking for an answer. So like 5, -1, 3, a half. And that's what your answer should be stated like. Sometimes we just can't evaluate them because it's going to be a decimal and we can't do that in our heads. So if you have something like log base 2 of 9, well, I know 2 to the power of 3 is 8, but 2 to the power of 4 is 16. So I know it's going to be in between 3 and 4. I know it's going to be closer to the number 3, but I don't know what it's going to be. So sometimes we have to use this thing called a change of base formula. And a change of base formula works like this. We can change this so that it actually has, instead of a base of 2, we can change it so it has a base 10. So I can change this to say log 9 divided by log 2. And that just automatically puts a base 10 in our log, which is what the calculators are using. So then I just go to my calculator and I just punch in log 9 divided by log 2. And I will get 3.17 approximately. So that would have been hard to calculate on our own. We would have had to just guess. We would have had to just say like 3.1, 3.2. So this is a nice way to do it. Okay, this one. So now it's in exponential form and I can't figure it out. 3 to the power of what equals 44? I don't know. I know like, sorry. I know like 3 to the power of 3 is 27. And then I know 3 to the power of 4 is 81. So I know it's going to be between 3 and 4, but I don't know what it's going to be. So I'm going to swap this into log form. So I'm going to say log base 3 of 44 is equal to x. And then I'm going to use my change of base formula to solve. So now I'm going to say log 44 divided by log 3 is equal to x. And then I'm going to use my calculator. So I'm going to say log 44 divided by log 3, and I get 3.44. I should specify too, the change of base formula, you can change it to a log of any base. We just choose a base 10 because that's what our calculator does. You could also change it to a log that has a base e. So a log with base e, we actually write as ln. We pronounce it ln. So you could also do ln 9 divided by ln 2. Like, same thing, it doesn't really matter. But that is on our calculator as well. Okay, moving on. Oh, no, I'm going to save that for another video. Okay, that's it.